engineers!
So today we're going to perform an experiment entitled
Field density test by sand cone replacement method.
All of the procedures of this experiment are in accordance with the ASTM D1556 guidelines. Sand cone replacement method. The sand cone method employs the use of uniformly graded sand to fill a test hole. The hole is hand excavated in the soil and all the materials from the hole is saved in a container. It is used to determine the in-place density of any soil that can be excavated to a stable condition with hand tools. To start, we will be needing the following materials. First, the sand cone density apparatus, which consists of sand container, sand cone, and base plate. Second, the equipment that we would be using are triple beam balance and the drying oven. Lastly, the miscellaneous tools that would further aid us in this experiment are the shovel, digging bar, tin pan, and sieve number 10.
First, we're going to weigh the equipment.
The sand container must be weighted to find its mass and volume. Next, get the mass of the tin pan.
The sand sample must be clear, dry, and free-flowing. To sieve, use sieve number 10.
In obtaining the sand density, we need to first fill the sand container with sand. Once filled, we are going to weigh the container in order for us to obtain the mass of sand. And then by using the formula for density, we can then get the density of the sand.
To calibrate the sand cone, you must first get the base plate and put it on a flat surface. Next is to put the sand in the sand cone and to level it using a laboratory spatula.
Afterwards, we need to record the mass of the remaining sand in the device, which would then be used to calculate the mass of the sand on the base plate.
So for the excavated test hole, we're going to get the soil specimen from it and then weigh it. After weighing the soil specimen, we're going to put it in a drying oven for the next 24 hours. Now going back to the excavated soil, we're going to fill it with the sand sample and then get the remaining sand, weigh it for us to obtain the volume. And then after 24 hours, we're going to get the dried soil and then weigh it after so that we can get the moisture content and then the unit weight of the soil.
After all the procedures has been performed, we are now going to evaluate the results that we have gotten. Results and discussions. In order for us to get the sand density, we need to use the density formula of mass over volume. In this case, the sand density is equal to 1.26 grams per cubic centimeter. Next, in order for us to obtain the unit weight of the sand, we need to multiply the sand density by the acceleration of gravity, which is equal to 13.993 grams per cubic centimeter meters per second squared. In order for us to get the moisture content of the soil, we need to find the difference between the mass of the moist soil and the mass of the dry soil, which would then be divided by the mass of the dry soil multiplied by 100. In this case, the moisture content of the soil sample that we have is 29.63%. Next up is the moist soil in situ density. We're going to still use the same density formula, which is moist soil mass over the volume of the hole, which is then 1.228 grams per cubic centimeter. For the dry soil in situ density, still the same formula, mass of the dry soil over the whole volume, which is equal to 0.947 grams per cubic centimeter. Under normal conditions, soil is weakest when it is scorched. However, when there is a substantial amount of moisture within the soil, the tightly fitted water molecules provide added support and grip due to the formation of air-water interfaces. By establishing that the soil holds enough moisture, that is when you know how much weight it can sustain. In the data gathered, the moisture content of the soil is 29%, which is relatively low for a moisture content, meaning the soil is heavily compacted. Therefore, the soil where the test hole is excavated was already in a strong or solid state prior to the experiment. Experiment 10 is brought to you by Marfori, Saludes, Maglunsod, Oro, Giling.
See you in the next experiment. Bye-bye!